Hello guys, welcome to my YouTube channel. In this video, I will talk about the maths that is involved behind the logistic regression hypothesis and why we are making use of sigmoid function. Also, why we cannot simply directly use the hypothesis that we have for linear regression. Okay, so let's start. So as we all know, we will have a data set to be classified into two separate classes, either positive class or negative class. Given a data set, we have to classify that particular data whether it belongs to class 1 or class 2. Okay. So for example, let's say I have to classify based on the size of the tumor a person has, whether it is cancerous or not. Okay. On x-axis, I have size of the tumor, and here on y-axis, whether it is cancerous or not. Okay. Cancerous or not. If it's not, it will be 0. If it is cancerous, it will be 1. Okay. So now we all know that our linear regression hypothesis is theta transpose x. Okay. So what happens if we just apply this theta transpose x on this particular data set, which looks like this? Okay. So these are the points which are classified as not having cancer, and these are the points which are having cancer. Okay. We are still not up to classification. Okay. So these are the actual data points that we have. Now, using this hypothesis theta transpose x, if I fit a straight line to these points, the straight line would look something like this. Okay. And in order to classify, let's say we arrive at a threshold, let's say it is 0.5, and whatever this predicts, like, right, this theta transpose x line predicts, if it is greater than or equal to 0.5, we classify it as belonging to 1. If it is less than 0.5, we classify it as belonging to class 0, right? So with this data set, it looks like this theta transpose x is doing a fair job in classifying the data sets. Okay, because if you just look at this, if you just extend it, whatever data point falls behind this line will be classified as positive because the threshold will be more than 0.5, and whatever the data points lie behind this line will be classified as negative. So it is doing a fairly good job as of now, right? So what happens if we have a data point that is far beyond this particular axis? So let's say I have some data point here. Okay, this is my another data point which is having the size somewhat here, and it is of type cancerous. Okay, so in this case, if I use the same linear hypothesis here, linear regression hypothesis, this particular line will shift more towards this particular point here. Correct? Why? Because we are trying to reduce the distance between the predicted and actual values, right? In case of linear regression. So in order to reduce the overall cost, since it is having highest value, the line will be inclined towards this particular point. Now that we have this particular new straight line fitted to this data points here, if we consider the 0.5 threshold and extend this up to this particular point, and our new boundary will be this one, right? So whatever points lie behind this particular line will be classified as positive, and whatever points that lie behind this line will be classified as negative, right? So with respect to this data set, this linear hypothesis is doing good job only with respect to this data point, right? It is able to perfectly classify this as cancerous, but remaining cancerous cells, cancerous samples are being classified as non-cancerous. So this is a major flaw with using linear regression. Okay. So, and also the other point which I have covered in my part 1 video is that this linear regression will give us values not only between 0 and 1, but the values will be less than 0, and also it can be greater than 1, much less than 0 and much greater than 1, right? Because we use this for our continuous values, to predict our continuous values. That's why this is one of the other reason we cannot have the desired output when it comes to classification problem. Okay, so this is a simple explanation as to why we cannot use simple linear regression hypothesis for classifying data set. Okay, now let's say we have another data set here. Okay, simple explanation in order to make you guys more clear on the mathematics behind it. Let's say we have some negative points here, okay, and I have some positive data points here, okay. Now let's say this is the line which separates the negative and positive data points, okay. Now just understand this, there is an assumption for positive samples we treat them to be +1 which are belonging to positive class. With the data set which belongs to negative class, we treat them as -1, okay, not 0, -1. This is an assumption, okay. Just keep this in mind. This is just an assumption. So now, if we have something called as theta transpose x, right? So this theta transpose x is also considered as the distance between this line and the particular points that I have plotted here, okay. So the perpendicular distance between this particular point and this particular line which separates the positive and negative data points, okay. So now this theta transpose x will be positive for the points towards this part of the line, okay, and the theta transpose x will be negative for the points behind this particular line, okay. Negative theta transpose x and positive theta transpose x, right. Now let's say for each of these points, okay, since we have yi as +1 for the points beyond this particular line towards this direction, whatever value we multiply with y1 and theta transpose x, it will be greater than 0, correct, because theta transpose x will be a positive value and we are multiplying it with +1, it will be greater than 0, okay. Now if we have a negative sample belonging to class 0, we will end up multiplying -1 with theta transpose x, right. This theta transpose x will be again negative at this particular side of this line, right. That's why we are multiplying -1 with some negative value, again this will be 0, right. So right now we are good. Since it is greater than 0, we are classifying it correctly, correct, classifying it correctly. Now what happens if there is a data point which is negative, alright, at this particular part of this line. So while we calculate the theta transpose x using the linear hypothesis, the linear regression hypothesis, what happens is we end up discarding this particular line, okay, we discard this particular line, instead we may come across this particular dotted line here, okay. Now what happens, whatever values above this particular line will be treated as positive class, the values below this particular line will be treated as negative class, okay. Since because of just one training example which lies somewhere here can be treated as an outlier as well, our whole decision boundary which separates a positive and negative class gets distorted completely, right. Just to correctly classify this one particular data set, we end up misclassifying these many data sets, right. So this is another way to explain why hypothesis of the linear regression cannot be used as it is with respect to classifying the data set, okay. So what we want is, we want the values of our hypothesis with respect to logistic regression to lie between 0 and 1, right. So in order to have this, what we do is we end up with a sigmoid function which looks like this. This is 0, this is 1, this is 0.5, okay. And if I plot the sigmoid function, the curve will exactly pass through this particular line, this line at 0.5, and this will asymptote at 1, okay. So the values are always lying between 0 and 1, okay. So if you can treat it as x, or you can treat it as theta transpose x for now, okay, theta transpose x. So in order to have the values between 0 and 1, we are passing our linear hypothesis theta transpose x to some function, okay, f of theta transpose x. This f is called sigmoid, okay. This sigmoid will shrunk the values of this theta transpose x between 0 and 1. So in order for us to, let's say we have arrived at a threshold of 0.5 to classify to differentiate between positive and negative classes, okay. So if the value is greater than or equal to 0.5, we treat it as positive class. If it is less than 0.5, we treat it as negative class, okay. So in order for us to classify the positive classes, or in order for us to classify the positive and negative classes in a correct way, we want our theta transpose x to take some value, right. So if for positive examples, we want our theta transpose x to be greater than 0, right? Because at 0, this sigmoid curve passing through 0.5, since we have set the threshold as 0.5, we want our theta transpose x to be greater than 0 for all the positive examples, okay? So similarly, if the predicted hypothesis value is less than 0.5, we are predicting it as negative class, right? So for negative examples, we want theta transpose x to be less than 0, okay. It's greater than or equal to 0 because if the predicted hypothesis value is greater than or equal to 0.5, we classify that as belonging to class positive, class 1. If it is less than 0.5, we treat it as belonging to negative class or class 0. So in order for us to classify the negative examples correctly, we need theta transpose x to be less than 0, so that the threshold, the output of the sigmoid will be less than 0.5, so that we can classify it as belonging to negative class, okay. So this is about logistic regression, why we cannot simply make use of linear regression hypothesis as it is, and why we are shrinking the values between 0 and 1 so as to classify the data points correctly, okay. So this is it about this particular mathematical intuition behind the logistic regression hypothesis. In my next video, I will cover the cost function that we will be making use for logistic regression, okay. Till we see in the next video, guys, happy learning, bye bye.